Hello students. Today we'll be discussing about a topic that is meter bridge, and this is an application of a Wheatstone bridge principle. So the Wheatstone bridge principle, as we have already studied, that Wheatstone bridge principle consists of the four resistor, that is if you consider P, Q, R and S in the form of a bridge. So according to the Wheatstone bridge principle, we have P by Q is equals to R by S. This is our Wheatstone bridge principle. And the main Wheatstone bridge principle motive is to find out the unknown resistance in a circuit. Okay, so this meter bridge is also based on the Wheatstone bridge principle only. So here in the Wheatstone bridge principle, we have total 3 known resistor and we have 1 unknown resistor is there. Okay, so here if I consider here P, Q and R are the known resistor and S is the unknown resistor. From here we can determine that S will be equals to, we can write R by P into Q. Okay, here P and Q are the constant resistor and R we can consider as a variable resistor. So if I consider here in this meter bridge, so in this meter bridge here R is a known resistor and this is nothing but a resistance box. Okay, and this is your unknown resistor in which we have to calculate by using this meter bridge. So if you consider this is your meter bridge and this wire, that is from the wire A to B, okay, it has a length of total 1 meter. I'll be showing you a bridge in the photo. Please go to that photo. So if you see here, this is a meter bridge, then we have the 1 meter wire. Then what we have to connect, we have the connection with the resistance box. Then we have some terminals, as you have seen in a picture. We have some terminals. These terminals, A point will be connected to the positive terminal of the battery eliminator. Then B point will be connected to the battery eliminator, that is the negative terminal. So this battery eliminator is nothing but a source given to the circuit. Then we have these 2 points. Okay, first 2 points will be connecting a resistance box. Then from the middle point we'll be connecting a galvanometer. Okay, from where it will be connecting a jockey, and jockey is just like a type of rod which we use to scroll over the wire or tap over the wire to detect the current in the circuit. That means whether your current is flowing or not, and we, by using this, we detect the null deflection in the circuit. Okay, I'll be discussing what is a null deflection. Then at this point we'll be connecting the unknown resistance, or your wish, we can this unknown resistance can also be replaced here and a resistance box can be placed here. Okay, so now this is the connection of the meter bridge and we have a key below. Now after connecting the circuit, okay, after connecting the circuit, this resistance box we have to adjust in such a way, because this is nothing but a rheostat. We have to adjust the circuit in such a way that when you tap the jockey over the wire at a certain point, like suppose if you tap at the middle point of the wire, suppose around 52, 53 or around 50 centimeter of the wire, if you get the galvanometer deflection as 0, this means that that is a null deflection, or we call as a balance. The bridge is said to be balanced. Now from the point A to B, okay, why the galvanometer deflection has shown 0 deflection? Because as we know, when there will be no current flowing through the circuit, your galvanometer deflection will be always shown as a 0 current. Okay, now from the point A and the point B, okay, these 2 points, when the bridge is said to be balanced, this point A and point B will be having the same potential. Okay, because of which, like suppose if I consider the potential difference between A and B, so it is VA minus VB. And in the balanced Wheatstone bridge condition, this A and B has the same potential. So if it is have the same potential, your potential difference will be equal to 0. And if there is no potential difference, there will be no flow of the current in the circuit. That's why the current through the galvanometer becomes equals to 0. Now the bridge is balanced. Now we have to see R and S will be here, but where will be your P and Q? Suppose you are getting the balancing point at the point J. From the point A to the point J, this part will be behaving as a resistance P. Okay, resistance per unit length of the wire. Then from the J to B, this will be behaving as a resistance Q. Okay, so this will be P and the other part will be Q. Now according to Wheatstone bridge principle, if I use, we have considered that from point A to J, it is acting as P resistance, therefore P will be equals to R into L. Okay, similarly from point B to J, this will be behaving as a resistance Q. Okay, so this Q will be equals to, it will be equals to R, but suppose if this length is L, and I have already told that the total wire length of this A to B is 1 meter, that is equals to 100 centimeter. So if this is L, okay, if this part is L, okay, the remaining part will be this part, it will be 100 minus of L. So if I use Q resistance for that, so this will be equals to R into 100 minus of L, that is resistance per unit length. Now if I use the Wheatstone bridge principle, according to Wheatstone bridge principle, okay, Wheatstone bridge principle, what we'll be getting now, we'll be seeing Wheatstone bridge principle, it is P by Q is equals to R by S. Okay, so P by Q is equals to R by S. So P is nothing but R into L, and Q is nothing but R into 100 minus of L. So this will be equals to R by S. Similarly, from here I can calculate the value of S. So S will be equals to, here what I can do, I can cancel this R and I can cancel this R. Okay, so this S will be equals to, now it will be 100 minus of L divided by L into R. So this is the formula for determining the unknown resistance by using your meter bridge. So in the next class we'll be discussing about the same type of bridge we'll be discussing about the potentiometer. Okay, so this much for today.